Hi, I'm Paul Beckwith. I'm with the Laboratory for Paleoclimatology at the University of Ottawa. And what I want to show in this video is explain what's happening on the west coast of the US right now in California. What you can see here is the major fault lines. These are dots. This is from the USGS. These dots are earthquakes that have occurred in the last week or so. And you can see how they're concentrated here, up on this arm, and up in this arm. So this is like a tuning fork or a slingshot. Okay, so keep that in mind as I proceed through the presentation. Okay, so what you see here, this is February 25th at 1600 hours local time, and this is the carbon monoxide concentration, and you can see it's actually off the coastline here. What I'm going to do is now I'm going to cycle through, actually the next slide is 3 hours later. Okay, so you can see that there's a huge increase in the carbon monoxide level, a huge transition. Okay, so the next, it's not just carbon monoxide. This is CO2. That's 1600 hours on February 25th, and 1900 hours on the same day, so 3 hours later. This is sulfur dioxide at 1600 and at 1900. 3 different sensors on the satellite to measure these. This is not a detector problem. I'm going to demonstrate that this is a real output of the gases, and I'm also going to demonstrate that this is from the fault lines, the major fault lines in California, including the San Andreas fault. There's no doubt about that, and I will try to demonstrate that. Okay, so this is the, let's cycle through. I have images every 3 hours of carbon monoxide. Starting February 25th, 1600 hours local time. So you can see the big increase here, and then I cycle 3 hours later, you can see it develop and fill out in the center here. So the emissions are still coming out, still lots coming out. And then as I cycle through, you can see, okay, you can see it starting to decay a bit, but there's still lots of emissions of CO from the fault lines. And now look at this. Do you remember the boomerang, or the slingshot rather, or the tuning fork I was talking about? These are the main fault lines of the San Andreas up here. These are the major fault lines of California, and they're lit up. So this is a strong source. There's also sources at various points, I guess, where the Earth is weakened or fractured or ruptured. So let's continue on. You can see it very, very clearly there, the fork here, tuning fork if you like. You know, and you can see the progression. Now the source of the gas is decreasing, and you can see the diffusion of the gas over time. And so it starts to dissipate. Okay, so that's CO, that's carbon monoxide. The levels are as high as 40,000 parts per million. And you can see, if I come back here, parts per billion. Okay, the levels, I said parts per million, I misspoke. This is parts per billion levels. So you can see in these regions here, it's very, very high. This isn't the number, this is the number for the background. Okay, so is it a faulty detector? Well, this is just for carbon monoxide. Let's have a look at sulfur dioxide. Okay, this is a map. Once again, this is February 25th, 1600 local time, and you can see the SO2 levels. Now we'll cycle through here. Okay, you can see the clear increase here, which corresponds to fault lines in California. We'll keep going 3 more hours at a time. And you can see it filling in. Filling in more and more, and then now it's dissipating as the source of the gas is decreasing. It flared up again up here. This isn't a detector problem. It's impossible. It would not look like this. Let's have a look at carbon dioxide now. Same time frames as before. Okay, so this is the carbon dioxide, February 25th. Actually, this is at 1730 local time is when the data was taken. And you can see the levels going here. You can see the increase. So 3 hours later, 3 more hours, 3 more hours, more. And what you can see is, you can see the two forks here, one here and one here. The same as for the other gases. And I'll just continue on, and then it's starting to dissipate as we continue on. Okay, so this event happened simultaneously. The 3 gases were released. This is not instrumentation. There's no way this is instrumentation. Okay, so what is going on? What does this mean? Okay, well, a lot of research has to be done here. The first point is that these 3 gases, the CO2, the SO2, and the carbon monoxide, came out in time at this, within 3 hours, and were quite strong for a day or so, and then started to decrease and dissipate. The initial emission of these gases from the faults occurred on February 25th. Today's February 29th. There hasn't been a peep in mainstream media about this. There hasn't been anything from the USGS. There hasn't been anything from NOAA or NASA or anybody, and that will change now. There has to be a flurry of stuff because this video will help in getting that information out. We need to find out from the experts what is going on here. I've heard rumblings of instrumentation problem. There's no way this is instrumentation problem. I mean, get realistic. That's ridiculous. So what's happened? What does this mean for California? Well, there's not a lot of papers, but there is one paper, and you can go back. This CO release has happened before a major quake 9 years ago. So there was a connection found between CO emission and the earthquake. They looked at satellite remote sensing data collected around the time before and during and after a 7.6 magnitude earthquake shook Gujarat in western India 9 years ago, killing about 20,000 people and rendering thousands homeless. So there is precedence for this. Singh, one of the researchers in the paper reports written at the time, said that CO levels were measured by the Terra satellite. Okay, the CO concentrations were measured at different heights, and the total amount of the gas in a vertical column of air above the Earth's surface was measured. The satellite data showed a large peak in the CO concentrations, January 19th and 20th, so that was 9 years ago, a week before the main earthquake event, which happened it was a week later. On January 19th, the total CO in the vertical column was higher than usual. So let's go on. So the big earthquake hit, and what did I say it was? It was 7.6. Okay, so on January 26th, the 7.6 earthquake hit, and then the concentration of the gas dropped. So according to these scientists, the carbon monoxide was forced out of the earth due to the buildup of stress prior to the earthquake, influencing the hydrological regime around the epicenter. Also, an anomalous increase in land surface temperature was measured a few days prior to the earthquake, and this was measured by MODIS, and it's related to the CO. The increase in column CO and the other gases may have led to the higher temperatures. The anomaly right here. It may have enhanced the temperatures. So this is showing a clear coupling between the land and the atmosphere, the scientists report. Okay, so what does all this mean? Okay, so what it means is we've seen an anomalous, a very unusual, very strange event occurring on the major fault lines in California. Of course, we know California is riddled with fault lines. People are concerned about the big one. It's overdue. We know that that's the situation in California. We know that this event occurred 4 days ago, and there hasn't been a peep from the mainstream media, NOAA, all of these other groups. So I have to wonder why, what's going on. In this prior case, the gases came out, there was a major quake a week later. You know, we can't predict earthquakes, okay? But maybe we can use these signals that happen before a quake to sort of, maybe these gases coming out increase the probability of something happening soon. You know, there'd be a week or 2 weeks, or, you know, maybe more gases will come out. We haven't seen gases come out like this in the past. There's a lot of questions, a lot more questions than there is answers. I'm not claiming by any means that there will be a major earthquake in California, you know, in the next week. All I'm doing is presenting data, and it clearly shows the pattern, the spatial pattern of the emissions of these three gases and the temporal pattern of them, and there's no way it's detector failure. It doesn't make sense. You know, it's different detectors measuring different gases. You have a spectrometer, a laser spectrometer, and it tunes to the absorption lines of the gas, and it would be 3 different sensors measuring this, presumably. You know, not a grading tunable laser system. I won't get into the details of the optics of the detection systems. I don't know all of the details. But it's pretty clear that we need to ask a lot of questions and understand what is going on. So please have a look at my website, paulbeckwith.net, for more information. I'll be posting lots of stuff there in the next couple of days. I had a YouTube video filmed earlier today, so this one will be posted shortly. This research that I do is, I fund this just myself and from my part-time teaching. So I do have a please donate button on my website on the main taskbar on the far right. So please consider supporting my work and these videos if you are able to do that. Thank you for listening, and I'm sure I'll be talking a lot more on this, you know, over the next few days. Thanks.